Hi students, welcome to Future Doctor NEET Academy for the crash course live session. Topic today we are going to discuss is current electricity. This is from chapter 3. Chapter 3 from 12th standard current electricity. Previously we have discussed two units, two chapters. What is the name of the chapter? Chapter 1 is electric field and charges. That is first chapter. Second chapter, electrostatic potential and capacitance. And these two chapters are combinedly called one unit, that is only electrostatics or static electricity. What is static electricity or electrostatics? Electrostatics is the branch of physics that deals about the charges at rest. Study about the charges at rest. That is electrostatics. Now current electricity or electric current. What is current electricity? Opposite of rest. What is the opposite of rest? Motion. It is a branch of physics. Current electricity is the branch of physics that deals about the charges which are in motion. That is only current electricity. And here we want to study some of the terms. First, electric current. What is electric current? What is the symbol of electric current? What is the unit of electric current? Symbol of electric current is I. Okay. And what is electric current? It is the rate of flow of charges. Okay. Or flow of charges in a unit time. I equal to formula Q by T. Okay. What is I? I is a current, Q is a charge, T is a time. Rate of flow of charge, that is amount of charge flows in a given time. That is only current. What is the unit of current? Unit of current? Come on. Ampere, yes, ampere. Ampere is the unit of current. And already we have discussed in your chapter 2 in +1 in fundamental quantity, derived quantity there and all, it comes under fundamental quantities. Current is a fundamental quantity. And so I equal to Q by T. And this is the formula for steady current. Steady current. So what is steady current? And what is the other one? Steady current is a current in which charge flows with constant time. That is a steady current. Time is constant. Okay. And the other one is that is unsteady or varying current. For that, what is the formula means? I equal to dq by dt. That is change in q with respect to time. Okay. Here time is constant, here time also varying. Okay. Flow of charge with time, that time also may vary, that is a unsteady current. This is the formula for unsteady current. Okay. Suppose if you plot a graph, I along this axis and T along this axis. What is the name of this axis? X axis or Y axis? X axis. And I along Y axis. Then, for steady current, that is constant current, that is when time changes, current will be constant, like this. This is the steady current. Unsteady current means like this. This also change, current also change, time also change. Or this one. This is the unsteady current. Apart from that, some more current types are there. AC. What is AC? Alternating current. Alternating current, what is that? That is, this is alternating current. What is the difference between this and this? Here also time is changing, magnitude also changing. Not only magnitude, its direction also changes periodically. There is a change in the magnitude of current and also direction of current changes periodically. That is the AC current. What is the other type? DC. What is DC? Expansion of DC. Come on. Expansion of DC. Direct current. Direct current like this. This is a direct current. That is, what is DC current? Magnitude of current changes with time, but direction does not change. Same direction. Okay. This AC. AC gives AC current or DC current? AC is air condition. This AC gives AC current or DC current? AC current. This light, tube light, most of the tube light and all AC only, alternating current. Fan, rotating fan, AC or DC. Television, television DC. Most of the electronic equipments are DC. Okay, television is a direct current. Okay, right. Okay. So electric current, what is electric current? Electric current is the rate of flow of charges. Charge flows per unit time. While teaching, try to write. Okay. I equal to Q by T. So charge flows per unit time, and if it is steady current, constant current, then I equal to Q by T is the formula. And if it is unsteady current, then I equal to dQ by dt. That is, current will varies with time. And here current is constant with time. That is a steady current. So now in this graph, this is a steady current. This is steady current, and this is unsteady current. Okay, from next, while teaching, I am teaching slowly only. Try to write. Okay, don't expect time for writing separately. Okay, any doubt in this? No? Okay. So just I am repeating, that is what is current? You proceed, you write. That is, current is the rate of flow of charge or charge flows per unit time. I equal to Q by T, and SI unit of current is ampere. And for steady current, I equal to Q by T, that is, current is constant with the time. And for unsteady current, that is a change in magnitude with respect to time, I equal to dQ by dt. And this curve gives steady current. Current is constant with time. When time changes, current maintain constant. Unsteady current, when time changes, current also changing. And alternating current, when time changes, current, its magnitude changing and also direction also changing. Direction also changes periodically. That is the AC current. For DC, only magnitude changes, direction does not change. That is direct current. Okay. Now next topic is Ohm's law. State Ohm's law. State Ohm's law. Ohm's law states that V is proportional to I at constant temperature. At temperature constant. Okay. It is when current increases, V, potential difference also increases. When current decreases, potential difference also decreases. That is Ohm's law. State Ohm's law. Ohm's law states that potential difference is directly proportional to current. Current flows through a circuit at constant temperature. This is Ohm's law. And by removing proportionality, we will get constant. What is the name of that constant? That constant is R. R into I. Here R is a constant called resistance. R is a constant. Resistance or resistivity? Resistance. R is a constant called resistant. And when V increase, I increase. When V decrease, I decrease. But R maintained constant. That is called resistance. And so from this, R is equal to V by I. R is a resistance. What is the unit of resistance? Unit of resistance is ohm. Okay, unit of resistance is ohm. And its symbol is What is the name of the symbol? Read as ohm. It is capital omega. Okay, it should be read as capital omega. So resistance unit is ohm, or simply read as ohm, or that is omega, capital omega, or equal to V by I. Okay. And simple definition for resistance is the, what is that? It is a flow will be obstructed or resisted, that is the resistance. So when current flows through some material, for example, this material may be metals, that is the conductors, and other metal may be insulators, and this is the insulator. Then when we pass a current, in conductor current can flow easily, and in insulator current cannot flow easily. It obstructed. It means in both the cases there will be resistance is there, but in conductor low resistance, in insulator high resistance. Okay. That is why suppose in conductor if you send the current, for example I am saying 5 ampere current, here also we make it 5 ampere or 4.9 ampere, and it's an insulator, and here you are getting 5 ampere current, you may get 1 ampere or less than 1 ampere. Okay, so that resistance offered is more in insulator, and in conductor less. Low resistance, high resistance. Insulator is a high resistance and conductor is a low resistance. Okay, we said resistance R is constant, but this resistance will vary and depends upon some factor. Okay, noted, no? This resistance depends upon some factor. What is the factor? It's not from Ohm's law. Resistance depends upon length of the wire. Okay, L. And resistance depends upon area of cross section of a wire, thickness. Okay, suppose there is a wire, because wire, what's the shape of a wire? What's the shape of a wire, normal wire? Yes, cylindrical shape, good, cylindrical shape. Its area of cross section will be circular. And this is a thick wire, suppose consider thick wire. Okay, and L is the length of a wire, this is the length, maybe approximately some 5 or 7 centimeter. And thickness may be in 1 centimeter, less than 1 centimeter thickness. Okay, the thickness comes under area of cross section, area of cross section. Okay, and resistance depends upon these two factors, length of the wire or length of the material and area of cross section, that is R is proportional to L. When length increases, resistance increases. When length increase, resistance increase. When length decrease, resistance decrease. And what about area of cross section? R is inversely proportional to area of cross section. Okay, so R is proportional to L and R is inversely proportional to area of cross section. So if you increase the thickness, then resistance will be increase or decrease? Decrease. That is why in high voltage and all we will use thick wire. Thick wire if you use, then resistance will be less. Okay. So R is proportional to 1 by A or inversely proportional to A. Combining these two, R is proportional to L by A, and R equal to another constant we want to introduce. What is another constant? Resistivity, rho into L by A. Okay, what is rho? Rho is called constant called resistivity or specific resistance. Okay, rho is called resistivity or specific resistance. Resistivity, other name specific resistance. R equal to rho into L by A. Then from this rho equal to R equal to rho into L by A, rho equal to R into A by L. Is it so? Rho equal to means R into A divided by L. Then from this you can find the unit of resistivity or unit of specific resistance. What is the unit of resistance? Yes, unit of resistance. Come on. Previously only we discussed. What is the unit of resistance? Come on, just now only we discussed. Come on, see and say. Unit of resistance? Ohm. And unit of resistance is ohm and area. Area is pi r square, so your area is meter square. And length. What is the unit of length? Meter. By meter. Meter and square getting cancelled. Therefore, unit of resistance is ohm into meter. Okay. Unit of resistance is ohm into meter. So, this is the unit of resistivity or specific resistance. Try to write while teaching, okay. I am teaching very slowly only. So, as we said, resistance R is constant, we said R is proportional to L, but R depends upon some factor, that is length of the wire and area of cross section of the wire. So, R is proportional to L by A. Then R equal to rho into L by A, and here rho is another constant, that is called resistance or specific resistance, resistivity or specific resistance. Its unit is ohm into meter. Okay. And is this resistance, suppose I want to change the resistivity. How can we change the resistivity? I don't want, for example, I am using one material, that resistivity is, example I am saying just 5.6 into 10 power minus 8 ohm into meter. Then I don't want this number, I don't want this resistivity, I want to change. Then how can you change? Change the material. Instead of copper, silver if you use, we can get another resistivity. So, that is, resistivity depends upon type of the material, that only we are calling nature of the material. Nature of the material. Okay. So, suppose you want to change the material, then only resistivity will change. By changing the length, by changing the area of cross section, or by changing the current flow, by changing the potential difference, resistivity never change. It is a constant for a given material. For iron, fixed resistivity. For copper, fixed resistivity. Silver, fixed resistivity. Silver is a material containing least resistivity. Next to copper, iron, like that it goes. Okay. Okay. Let's move to next topic. In resistance, color code of a resistor, carbon resistor. Color code of a resistor, carbon resistor. In electronic equipments, you may observe that resistor, small resistor. It may contain some color rings. Is it so? Some color rings like this. Probably three color will be there, three rings will be there having different color, but here red color only. We can change the color also as per this, and after some gap at last another ring will be there. And depends upon the color we can say the value of resistor. That is given by a one code that is called B. Roy, Great Britain, very good W. These are the color. First one is black. Next brown, red, orange, yellow, and this is green, blue, violet, grey, last one white. These are the code for a color. For this, each is having digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So by saying the ring, we can say the value of a resistor, carbon resistor. Okay. And electronic equipment students, ECE students, EEE students, ECE is Electronics and Communication Engineering, EEE, Electrical and Electronics Engineering. These students are very well versed in this color. On saying the color itself, this is 10K, this is 20K, this is 22K, like that they will say immediately. That much they are thorough in practice. Okay. Similarly, even physics person also in BSc and MSc, they use electronics as a separate one paper. 2 practical will be there, general practical, another one special practical, that is electronics. There also will be well versed in this. Okay. And apart from that, for long string, tolerance will be there, tolerance percentage. Long string, no, that is mentioned as tolerance percentage. That is a gold 5%, silver 10%, no color, that is a no ring or no color, no ring, then 20%. This is tolerance. Okay. So from the ring color, we can say, for example, I will say one color. First ring is example brown. Okay. First ring is brown color. And the second ring, black color. This is black. And the third ring is, example I am saying, orange. Third ring is orange. And last ring, after a gap, last ring, example gold, which is costly. Okay. Then, first 2 ring is 2 significant figures. That is brown. For brown, what's the number? 1. Black? 0. So this is 2 significant numbers. Okay, 10. And third digit is 10 power n. Third digit is 10 power n. So into 10 power orange. For orange, what is the color? 3. So 10 power 3. Okay. So 10 into 10 power 3. That is called 10K ohm. 10,000 ohm. We will say this as a 10K ohm. Resistance of a given resistor, carbon resistor, is 10K ohm. Motorboards is tolerance. Gold. Gold how much? 5. So this we will write as plus or minus 5%. Okay. So combinedly 10 plus or minus 5 kilo ohm. 10 plus or minus 5% kilo ohm. So this is the value of the resistor. Okay. So by seeing the color code, we should identify, we can find the or calculate the resistance of a given carbon resistor. Okay. Suppose instead of orange, yellow. Instead of orange, last one, other things same. Instead of orange, if it is yellow. And instead of gold, no ring. Then what's the value? Come on, say. What's the value of resistor? Brown, same one, next to 0, into yellow. What's the value of yellow? 10 power 4. And plus or minus 20%. Okay. So 10 into 10 power 4, this you can write as 100 k ohm, 100 into 10 power 3. So 100 kilo ohm plus or minus 20%. Okay. So like this only we can determine the value of a resistor given carbon resistor. Okay. Next one. Okay, this over. Okay, next is temperature dependence on resistivity. Temperature dependence on resistivity. Your rho T is the resistivity at T temperature. That is when temperature increases, how is the resistivity? Okay. And rho naught is the temperature at 0 degrees Celsius. And T naught is the T temperature at 0 degrees Celsius. And alpha is the temperature coefficient of resistance. Temperature coefficient of resistance, that is alpha. Okay, that is only alpha. Alpha is the temperature coefficient of resistance. And I said already that for metals, that is for conductors, when temperature increases, its resistivity increases or decreases? For metals, when temperature increases, for example, if you plot a graph, resistivity along y-axis and temperature along x-axis. Okay. And when temperature increases, resistivity also increases. That may be like this. This is for conductors. For conductors, this will happen. Yes. And for insulator, when temperature increases, resistivity also increases linearly like this. Okay. And apart from these two, there is one material is there. Can you say? That is, one is conductor, another one insulator, one more material is there. What is the name? That is, that depends upon conductivity. Basically, materials are classified into two. One is conductor, another one insulator. What are conductor? That is, material which allow electrons to flow through them are called conductors. And what are insulator? Materials which does not allow electrons to flow through them. That is insulator. Apart from these two, one more material is there, one more type is there, one more classification is there. What is the name of that? That is only covered everything by in electronics. In electronics, what things are present inside? In electronics, semiconductor. Okay, semiconductor. I'll write here. So third one is there, but this one we are going to study in last two chapter only, semiconductor. Semiconductor means whose conductivity in between conductors and insulator. And only for semiconductor only, when temperature increases, resistivity decreases. Okay. For semiconductor, what is the example for, can you say any one example for semiconducting material? For conductor, you may say example. What is the example for conductor? Yes. Example for conductor. Metals, all the metals are conductors. Example for insulator? Plastic, wood, these are all glass, these are all insulator. Like that semiconductor example, what is this? Germanium, silicon. Germanium and silicon are the best example for semiconductor. Okay. So, temperature dependence of resistivity means depends upon the material, we will say. So, based on the resistivity only, we classified as 3 types. One is conductor, another one insulator, and semiconductor. Okay. Okay, color code over. Okay, can we move to next topic? Suppose resistors are connected in a circuit in different way. That is, resistance connected in series. What is the symbol of resistance? This is the symbol for resistance as R. Suppose 3 resistors connected in series like this. Then we can say this is resistance connected in series. Okay. As R1, R2, R3. 3 resistors which are connected in series with a battery. Some battery, V is the voltage of a battery. Okay. And already we have discussed that when it is connected in series, in capacitance of a capacitor, we have discussed that when something is connected in series, what about the potential? Potential will be divided or same? Divide. Is it so? So this will be V1, V2, V3. Is it so? Correct? No. Then, so current will be, their charge is constant, we discussed. So here current will be constant. For example, I am saying this is 220 volts or 200 volt, 220 volt will keep. And here there may be a 100 volts, and here may be 100 volt. Here 120 volts. Then V equal to V1 plus V2 plus V3. Sum of that. Okay. And V equal to Ri, we know the formula. Okay. Then R into I equal to R1 into I, because current is same we said. Current, for example, here 5 ampere current. Here also 5 ampere, here also 5 ampere, here also 5 ampere. Then R1I plus R2I plus R3I. Take I outside, II getting cancelled. Then R equal to R1 plus R2 plus R3. Because I is common, take out, getting cancelled. Okay. Then R equal to R1 plus R2 plus R3. Now, this R is called effective resistance. So, when resistance connected in series, then R effective equal to R1 plus R2 plus R3, sum of the resistor. when 3 resistors or number of resistors connected in series, then effective resistance is the sum of the individual resistor. Okay, sum of the individual resistor, or effective equal to R1 plus R2 plus R3, or effective or R equivalent. We can say this as a R equivalent also. Okay. Next, when resistors connected in parallel. Parallel manner. Three resistors connected in parallel manner. R1, R2, R3, R1, R2, R3, 3 different resistors connected parallel. Then, if it is connected in parallel, here which is constant? In previous, current is constant, V is variable. Here, V is constant, current is variable. Suppose here 220 volt, here also if you measure 220 volt, 220 volt, 220 volt. Now, V is constant and current is variable, I1, I2, I3. Then, I equal to I1 plus I2 plus I3. Ohm's law, what is the formula for Ohm's law? V equal to, formula for Ohm's law, V equal to Ri. V equal to Ri. V1 equal to Ri1. V2 or V equal to R2, I2, like that. Okay. Then, by substituting this, and I equal to, V equal to Ri, then I1 equal to V by R. Similarly, I2 equal to V by R1, yes, R1, R2, and I3 equal to V by R3. Substituting this here, I equal to, what is I? V equal to Ri. From that, I equal to V by R. Here R is the R effective. Then substituting this here, I equal to V by R effective. V by R effective equal to I1 is V by R1 plus V by R2 plus V by R3. V is common, take out, V getting cancelled. Then 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now, when resistors connected in parallel, then its reciprocal of the effective resistance equal to sum of the reciprocal of the individual resistor. Okay, 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Any doubt in this? No. Okay. Can we move next topic? Cell or battery. Okay. Battery or cell. For example, you are using in our normal remote and all, small cell. What's the name of that cell? That may be like this. Is it so? One side positive and here there will be like this, that will be negative. What's the name of that cell? Try to find the name of that cell. Okay. Okay. There is one name for this. And find the name of the cell, what we are using in our remote and all, and how much voltage it produces. V equal to how much. These two in next session, next class, you want to find and inform me. Okay, right. Cell or battery, it contains particular value that we are calling EMF. EMF means electromotive force. Okay, electromotive force. That is called EMF. And EMF also denoted by E only actually, but its unit is volts. EMF is measured in volt only and the symbol is E. Then we used potential difference V. What is the difference between potential difference and E? E equal to I minus R into V minus R I. Okay. Here R is the internal resistance. One minute. V equal to E minus R I. Yes. I equal to E by V plus R plus R. Okay. EMF equal to V minus R I. R is the internal resistance of a cell. Internal resistance. Resistance of a cell. Okay. And another one, I equal to V by R plus R. Here V is a potential, I is a current, R is the total resistance of the cell, and small r is the internal resistance. What is internal resistance? Internal resistance is a resistance offered due to electrolyte of a cell. Internal resistance is the resistance offered due to electrolyte of the cell. That is only internal resistance or internal resistance of a battery. Okay, battery has some resistance, that only internal resistance. I equal to V by R plus R. Yes, this we discussed. V plus here, V plus RI. And there is a small difference between EMF and potential. E equal to V plus RI, and E is a EMF I said, and V is a potential difference. What is the difference between EMF and potential difference? That is, EMF is the, we are measuring the value of the potential difference or potential value in the open circuit. In the open circuit. Open circuit means without drawing current. Okay, we are measuring the value of potential without drawing a current, without using a current. That is only open circuit. And V is a potential difference in closed circuit. Closed circuit, that is potential difference. EMF is the value of the potential difference in open circuit, and V is the value of the potential difference in closed circuit. Some more explanation of this I will explain when you set the answer for this. What is the question? That is, what is the name of the cell we are using in normal our torch and all, torch remote there and all, and what is the value? And if you say the value, try to find the value. From that, I will explain some more this in the same session, next session. Okay. Right. Next topic is Kirchhoff's law. First law is called current law. First law is called current law. It states that, or junction rule, its other name is junction rule. For example, there is a circuit like this. I1 is a current and this is a junction, and I2 is a current like this, and I3 is a current like this, I4 is a current like this. State Kirchhoff's first law or current law or junction rule. It states that algebraic sum of the current in a junction is equal to 0. What is current law? Algebraic sum of the current flowing into any junction is equal to 0, or current flows towards the junction is equal to current flows away from the junction. Sum of the current flowing towards the junction is equal to sum of the current flowing away from the junction. Okay, this is the junction point. Example, A is a junction point. Come on, say, which current and all going towards the junction? Come on. I1 is, and then I2, and then, oh, all are going inside. No, I2 is moving away. I3 only. I3 is moving, and then I4 is also moving, is equal to, what is the current flowing away from the junction? I2. This is Kirchhoff's first law. Okay, that is sum of the current flowing towards the junction equal to sum of the current flowing away from the junction. What is the first statement? Algebraic sum of the current flowing through the junction is equal to 0. That is, bring this I2 this side. Then what will come? If plus I2 come this side, plus I2 come this side, minus I2. I1 minus I2 plus I3 plus I4 equal to 0. Both are same statement. Okay. State Kirchhoff current law, first law or junction rule, algebraic sum of the current. Algebraic sum means summation of I equal to 0. Algebraic sum of the current flowing towards the junction. Algebraic sum of the current is equal to 0, or sum of the current flowing towards the junction is equal to flowing away from the junction. This is Kirchhoff's current law. Current law or junction rule. Okay. Okay, understand no? Okay. Let's move to next rule, second law. Voltage law. And what's the name of other rule? Loop rule, yes. So this is voltage law or loop rule. Voltage law or loop rule states that sum of the product of the current and resistance is equal to current and resistance in a closed circuit is equal to EMF, sum of the EMF of that circuit, that closed circuit. This is voltage law. Okay, sum of the current and product of the current and resistance in a closed circuit is equal to EMF of that circuit. This is only voltage law or loop rule. For example, this is a one resistor and here is another resistor. Here one battery and here another resistor R3, R1, R2, R3 and here another battery. Two battery. Here this is E1 and this is E2. And because of E1, I1 is the current flows here. What is the direction of current? Current moves from positive to negative. So I1 is current flows in this direction. I1 current. Okay. And here, we'll see here. Here I2. I2 is a current flows towards this side. Okay. And here what current is flowing? Here also I2 only moving from positive to negative. So negative I2. Now I into R, I1 into, and you want to say one direction. Suppose clockwise direction, take as negative. I into R consider as negative. This is a clockwise direction, is it so? For clockwise direction, consider that as negative. So minus I1 R1. And what this direction? Same direction or anti-clockwise, opposite direction. So plus I2 R2. And this is also opposite direction, is it so? So plus I2 R3. Okay, I3 R3 is equal to E2. Okay, E2 and then it is moving opposite, so E2 minus E1. Okay. So this is the voltage law. No doubt. Here minus E2 is there, no? Minus here plus. Yes. Actually, it's against the direction of current. So here is minus and here is plus. Okay. Minus E2 plus E1. So this is only voltage law. State voltage law, it states that sum of the product of the current and resistance in a closed circuit, this is applicable only for closed circuit, is equal to sum of its EMF in the same closed circuit. This is Kirchhoff voltage law or loop rule. Okay. Any doubt in this? No. Okay. We move to next topic. Yes, Wheatstone bridge. What is the time? 3:04. Okay. Next topic is Wheatstone bridge. Wheatstone bridge. This is a Wheatstone bridge having 4 resistor. R1, R2, we'll keep here R2, R2, here R3, R4. And here will be a galvanometer. Actually, the application of Kirchhoff law is in Wheatstone bridge. Okay. Uses or application of Kirchhoff law, that is Wheatstone bridge. And here 4 resistors will be used, and here one resistance will be unknown resistance. Okay. And other 2 resistance will be, other 3 resistance will be known resistance. One is unknown and other 2 will be maybe as a wire like that. That we are going to see in meter bridge. Okay. So maybe R1 is one unknown resistance, R1, R2. One will be known, other will be unknown. R3, R4 as a some fixed resistance. That will be replaced as wire. Okay. And here by bridge balance means galvanometer. What is galvanometer? Galvanometer is a device used to measure current or find the flow of current. Suppose current flows in this direction, example, then galvanometer shows this side deflection. And suppose current flows in this direction, galvanometer shows this side deflection. So maybe equal and opposite. Okay. And wherever we will use galvanometer, we will try to find for null deflection or zero deflection. Zero or null deflection. That is the purpose of using galvanometer. Okay. And if galvanometer comes to 0, then that is called bridge balance. Bridge is in balance condition. That is the balance condition of a bridge. That is Wheatstone bridge. Okay. Now, for balancing a bridge, what is the formula means? R1 by R2 equal to R3 by R4. This is the condition for bridge balance. When this will be possible or applicable, we have to adjust the galvanometer using rheostat such that galvanometer should show zero deflection. Galvanometer obviously that means deflection will be there, center 0, and here 10, 20, 30 like that. Okay. 10, 20, 30 like that, and middle deflection is 0. Okay. And we have to adjust using rheostat such that it should show zero deflection or null deflection. Then during null deflection, bridge will be balanced. It will be balanced. Then R1 by R2 equal to R3 by R4. Okay, R1 by R2 equal to R3 by R4. And this application is meter bridge. Where it's applying means we are applying in the meter bridge. Meter bridge is the modified form of the Wheatstone bridge. That is only meter bridge. Meter bridge is the modified form of Wheatstone bridge. Okay. And in meter bridge, 2 wires R3, R4 may be replaced by 1 meter wire. Okay. 1 meter wire as A, B. And then there will be a 2 gap. Here 1 gap, here 1 gap, and here another gap. And here 1 resistor. Maybe R1. And here another resistor as R2. And AB is the length of the wire. Okay. And this AB only contains 2 length, 2 resistors. And here there will be one more circuit connected to high resistance, key and jockey. And A to J, that distance will be L1 and J to B will be L2. Okay. So R1 is the unknown resistance and R2 is a known resistance, fixed resistance. Okay. Okay. Then R3 and R4 only replaced by this 1 meter wire. Then R1 by R2 equal to L1 by L2. Actually, how is that? Means there will be a 1 meter wire which is stretched on a wooden board and this connection dots should be given. R1 is an unknown resistance, some wire will be given and you want to find the resistance of the wire. R2, there is a resistance box. You are only going to give the value of resistance, 1 ohm, 2 ohm, like that. Or the circuit will be connected like this. High resistance, one thing will be a key, is a switch and a jockey. And bridge balance, we want to touch the jockey at this end and this end. After connection, switch on the battery and then connection should be given like this. And here there will be a battery, one other side will be battery. Like this. Okay. And then now when electric field is switched on and check this jockey touched at 2 points, at A point and B point. If the galvanometer shows opposite deflection, then bridge will be in balance. Bridge balance condition will be there. Bridge in balanced condition. Then what you want to do? Resistance R value, that is R2 value, 1 ohm. For 1 ohm resistor, bring the jockey, adjust the jockey such that galvanometer should show 0 deflection. And note down L1 and L2. L1, if you know, you can find L2 because it's a 1 meter wire. Suppose 60 centimeter is L1, then L2 will be is a 1 meter wire, and if L1 equal to 60 centimeter, then what about L2? L2 also 60. It's a 1 meter wire. This is a 1 meter wire. L1 equal to 60 centimeter. Then L2 equal to 1 meter means how much? 100 centimeter is 1 meter. Is it so? And in 100 centimeter wire, this is 60 centimeter. Then what about remaining thing? 40 centimeter. L2 equal to 40 centimeter. And R2 you are only giving. First we are giving 1 ohm. Then note down L1, L2 with R1. Okay, there is R2. R2 equal to 1 ohm, example I am saying. Then adjust the resistance to 2 ohm. Then L1, L2 will change. Note down the L1, L2. And R2 adjust to 3 ohm, 4 ohm, 5 ohm. Note down different L1, L2 value. Okay, and the tabular column will be there. R1, R2 like that, and then simplify this, then you will get R1 value, R1 equal to R2 into L2 by, L1 by L2 as per this, L1 by L2. So last tabular column it will become as constant. Okay, so for a different resistance value, L1, L2 will change, but R1 will be constant value. By changing R2, you will get different L1, L2, and R1, for example, is a 10 ohm resistor or 5 ohm resistor. All the value will come in 4.9 something or 5.12 something like that. Average if you take, it will come as 5 ohm. Okay, so the resistance, unknown resistance value will be 5 ohm. What's the use of meter bridge? Meter bridge is used to find the unknown resistance of a material. So for this is the modified form of Wheatstone bridge only. So Wheatstone bridge modified form is meter bridge. Okay, so that is R3, R4 are replaced by L1, L2. Okay, this R3, R4 only replaced by L1, L2. Instead of R3, R4, L1, L2. Okay, and this Wheatstone bridge is the application for voltage law or Kirchhoff law. Kirchhoff law application is here, and that modified form is meter bridge. Okay, now only one topic in pending in this chapter, that is potentiometer. If you finish potentiometer, this chapter current electricity will be completed. Okay, any doubt in this? Any doubts? No. Okay. And in problems later we are going to discuss for a given resistor R2, L1 value, L2 value will be given in different way, indirect way, and you want to find the resistance of the unknown value, unknown material. So that is the application, or in problems we will discuss. Next to potentiometer. Potentiometer is a device used to determine main thing EMF of a cell. EMF or EMF, anything. What is EMF? Just now only we discussed. Electromotive force. Its unit is volt only and its symbol is E, we discussed. Okay, that is the potentiometer. And in potentiometer, it is a 10-meter wire. That will be kept as just AB here as usual, just like meter bridge. Okay. And actually always that means start from A and it will go like this. 5 times it will go, and 10-meter wire. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So AB. This will be kept as just AB. Okay. And here our aim is to find EMF of a cell. EMF. EMF is a electromotive force. Actually, I said no, the normal our battery name you are going to find. That value how much? For example, I am saying its value is 2 volt. It's not 2 volt. Example, I am saying 2 volt. And how we will measure that is 2 volt or not? That battery, I want to ask, this battery is used up or not, new or new used up battery. I want to ask you to check it. How you will find out? That battery, that cell contains 2 volt or less than 2 volt. After some 1 or 2 months, what will happen? It will be reduced. How you will check it? Using voltmeter only. Is it so? Voltmeter, we can check it. Or multimeter. Okay. And but voltmeter is not measuring EMF accurately. Voltmeter will measure potential difference only, not EMF. Okay. That answer I asked you, no? That is a question I asked. What is the question I asked for yesterday? That is a for tomorrow question. Value of battery. And what is the name of the battery? What we are using in that normal torch cell remote and all. Okay. And example I said if it is 2 volts. And we can measure using voltmeter. But if you use to measure in voltmeter, that is not EMF. That is potential difference value only. Then only potentiometer is a device which is used to measure the EMF of a cell or EMF of a battery. Okay. We can measure the EMF of a battery only using potentiometer. Okay. And here 2 cells will be used. One cell will be Daniell cell, mostly used one. Daniell cell, another one Leclanche cell. These are the mostly used cell, and mostly we are going to compare the EMF of these two cell only. And EMF of the Daniel cell approximately 1.08 volts, and E2 is the EMF of a Lakeland cell 1.5 volts. And we will compare the EMF of these two cell only. Okay, let's note down, and then I'll explain for EMF of the cell. And potentiometer is a device used to compare the EMF of a cell, also used to determine the EMF of a cell. Okay. This is a potentiometer, 10-meter wire, goes like this. AB I mentioned, able to see, no? Okay, and this is a Lakeland cell, this is Daniel cell. Lakeland cell, Daniel cell. Okay, Lakeland cell 1.5 volt, Daniel cell 1.08 volt. And actual circuit diagram like this, A, B, that only I am going to do, and then battery like that. And a two cell will be used here. E1 one cell, E2 another cell. Okay, and other side battery, ammeter, here like that. It will be correct with A in Kerala. Known cell, unknown cell. Battery key rheostat. And here only battery key. Wait, better to use this way, A, B. Wait 1 minute. Use of this, A, B like this will be easy to understand. A will be here, yes, that will be best. This is A, B. Okay, this way easy to understand. From A, ammeter, battery, high resistance. Key rheostat. Key rheostat, and from here, from A only, cell. E1 one cell, E2 another cell. And then connected to high resistance and then jockey. Jockey may be connected anywhere in between this. Okay. A and B end. This goes as A and B, it will be 10 meter wire. And then when electric field is switched on, then E1 by E2 equal to L1 by L2. L1 is a balancing length for E1 and L2 is a balancing length for E2. L1 is a balancing length for E1, L2 is a balancing length of E2. And E1 by E2 equal to L1 by L2, or E1 equal to E2 into L1 by L2. Okay. E1 equal to E2 into L1 by L2.